Hello, in this video I'm going to talk about cyclic processes. So this is an example of a cyclic process. We start from stage 1, ends up at state 2, moves on to state 3, and then state 4, and then back to state 1. So if you return to the original state, you are a cyclic process. And a cyclic process will always enclose a loop. All that's required of you for the A level is to be able to figure out the meaning of the enclosed area. This is an example of a cyclic process consisting of 2 isobaric processes and 2 isochoric processes. Let's think about the work done during these 4 processes. So going from 1 to 2, we have work done by the gas that's equals to this amount because it's an expansion, right? So this area corresponds to the work done by the gas. There's no change in volume here, so there's no work done. Then going from 3 to 4, the gas got compressed. So this area represents the work done on the gas. Going from 4 to 1, again, there's no work done because there's no volume change. So if this big rectangle is the work done by the gas and this small rectangle is the work done on the gas, then the difference in these 2 rectangles, which is the enclosed area, will be overall work done by the gas. Get it? Because the work done by the gas is more than the work done on the gas. So net work done is by the gas. Let's bring in the first law. Now delta U is always 0 for a cyclic process. This is important because you return to the same stage, right? So you are back to the same PV and T. So you are back to the same 3/2 nRT. So you are back to the same internal energy. So there's no change in your internal energy whenever you complete one cycle. So delta U is 0. For this particular cyclic process, we have concluded that net work done is by the gas. So net work done on the gas will be negative. So if delta U is 0 and work done on the gas negative, Q must be positive. In fact, because delta U is 0, we can write Q to be negative work done on the gas. For this particular one, it might be more convenient to write it as Q is equals to work done by the gas. Meaning in this cyclic process, in each cycle, the net work done is by the gas, and this requires an input of heat into the system. So this enclosed area not only represents the work done by the gas, it also represents the required heat input during each cycle. Now what if we reverse the direction? So this cyclic process is the same as the one before, it's just that now it's going in this direction instead. So this time around, this big rectangle represents the work done on the gas because this is a compression. Whereas a small rectangle represents the work done by the gas. So the work done on the gas is more than the work done by the gas, which means overall, we have work done on the gas, represented by the enclosed area. So let's bring in the first law. So delta U is 0 because in a cyclic process, you always return to the original state. The work done on the gas this time is positive, which means the net heat supply is negative. Since delta U is 0, we can write Q to be negative work done on the gas, which means during every cycle, the system is losing heat to the surrounding overall. So this area here not only represents the work done on the gas, it also represents the amount of heat loss to the surrounding. Now in general, any clockwise cyclic process implies net work done by the gas, because when it's the gas turn to push, it pushes at high pressure. When it's the environment's turn to do the work, they do it at lower pressure. So the work done by the gas is always larger than the work done on the gas. So overall, you have net work done by the gas. So because work done on the gas is negative, heat supply must be positive. So this area not only represents the work done by the gas, it also represents the required heat supply during each cycle. On the other hand, every anti-clockwise cyclic process implies that there's net work done on the gas because the compression always takes place at a higher pressure compared to expansion. So if net work done is positive, then net heat supply must be negative. So the enclosed area not only represents the net work done on the gas, it also represents the net heat loss to the surrounding during each complete cycle. Alright, that's all. Ta-ta!